All right, section 8.6. All right, so here we are given an inequality. It wants to know where is x minus 4 times x plus 2 less than 0. Well, if you're less than 0, that means you're negative. So one way to figure this out, okay, and this is the way we'll work number 1. You've got x minus 4, x plus 2, and it wants to know where that is less than 0, or in other words, where would these things be negative? So let's think. So this factor is x minus 4. We'll want to know where is it less than 0. X plus 2 less than 0. Let's go ahead and solve them each for x to find out the solution. So just add 4's here. So x is less than 4. There, subtract 2. X is less than negative 2. So let's put these on a number line, these two numbers. And we're going to break up this number line, which we're going to kind of consider our x-axis. Okay, so think of this as your x-axis, into 3 different areas. So we'll put these in order on the number line. So negative 2 will come first. 4 will come next. So we're going to choose what are called test points. So what I'm going to do is choose 3 test points, a test number in this area of the number line, so anything below negative 2. So we'll just say negative 3. I also want to choose one that's in between these. So any number in between negative 2 and 4 will work. I'm just going to choose 0 because I feel like that's always the easiest. And then any number in this section of the number line, so any number bigger than 4, which would be 5. So those are going to be our test numbers. Now, I'm going to set these up. So let's see. This x minus 2 came from this factor here. So we'll just plug it. We'll make this one area. The 4 came from x minus 4. Now, we're going to think of these multiplied together. And all we really need to know is the sign of what the answer would be when I multiplied it together. And since the answer to a multiplication problem is called the product, I'm just going to call this column the product. So let's plug each of these numbers in to where they came from. So let's see. The negative 3, if you plug it in here, all I need to know is what the sign of that would be. So let's see. If I put negative 3 here, I'd have negative 3 plus 2, which gives me negative 1. So again, I just need to know that it's negative. If I put a negative 3 here, negative 3 minus 4 also gives me a negative. So what happens if you multiply these two numbers together? Negative times a negative is a positive. Let's do the same thing with the 0 and the 5. If I plug a 0 in here, I'll have 0 plus 2, so that's positive. 0 minus 4, well, that's negative. And if you multiply these together, a positive times a negative is a negative. And then do the last one. If I plug a 5 in here, 5 plus 2 is 7, so that's positive. 5 minus 4 is 1, so that's also positive. And if I multiply two positives together, I get a positive. So since it says less than, this is where this becomes important. Less than 0 means negative. So here's where the situation was negative, or below 0, or below the x-axis. So where did this number come from? What test area did it come from? It was in here, right? 0 is in between here. So it means every number that you would have plugged in, if it would have been between negative 2 and 4, this would have happened. You would end up with a negative product, which means below 0, which means where is this function less than 0 or below 0? In between negative 2 and 4. That would be your solution. Okay, now on number 2, let's show you what this would look like on a graph. So let's go to my y equals and clear it out. So again, just think about that that last problem's number line being the x-axis, and we're talking about above or below the x-axis. So let's see where this one is. So I need to know x squared. So x squared minus 15x plus 54. Oh, whoops, hang on. Let's see what this looks like on a graph. Oh, I shouldn't have. I guess I shouldn't have. Let's go back to. I don't know why it's still. Let's try it again. Go to y equals x squared minus 15x plus 54 and graph it. Why is this not graph it? Okay, there it is. I don't know what was wrong. Okay, so there is the graph of x squared minus 15x plus 54. So remember the last question. We were thinking about this right here, that number line that we drew and separated it into 3 areas. Well, these are the 3 areas right here, below, in the middle, and then on this side in the x-axis. So this time, look at what it's looking for though. It wants to know where this function is greater than 0, which means where is it above the x-axis or positive. So if I'm looking at it on the graph, it's above it all the way to there. Then it drops below it from here to here. And then it goes above it again right here. So I need to find out those 2 spots, those 2 numbers. Okay, those are the solutions or the x-intercepts. Okay, and you can kind of look at it here. You can, since these are good numbers, 1, 2, 3, 4, 5, it crosses it at the 6, 7, 8, 9. So that's 6 and 9 on the x-axis. So where is it above the x-axis? All the way forever to 6. So from negative infinity to 6 in union with, here, remember, here's where we don't want to include. That's negative or below the x-axis. Then where does it go above again? Starting at the 9 to infinity. Okay, so negative infinity to 6 and then 9 to infinity. All right, same thing on number 3. Number 3, I just have to do a little bit of work before I can plug that into my x-axis because, or my y equals, because this right here needs to go on this side. This has to be a 0 over here. So if I have x squared minus 2x minus 13 is greater than or equal to x minus 3, before I can plug that into my y equals, I need to have this side be a 0, which means I need to subtract x and add 3 to make that side a 0. So minus x plus 3. So now let's see what I have. I've got x squared. Then I have negative 2x and negative x that I put over here, so negative 3x. And then negative 13 plus 3 gives me negative 10 is greater than or equal to 0, right? Because that side canceled out. So here's what we're putting in our y equals. So go to y equals and clear it out again. So x squared minus 3x minus 10, and then graph it. So let's look. Where does it want to know? It wants to know where is this function greater than or equal to. Anytime you see that equal to, you're going to put a bracket around that number because you want to include that number this time. Where is it greater than or equal to the 0? And you have to think of the 0 being this x-axis. Okay? So let's see, where does it cross? It crosses at negative 2, 1, 2, 3, 4, 5, and 5. So where is it above the x-axis? All of this and all of this. Below it would be this part that falls below it. So this is the part that we don't want to include. So not this part of the x-axis. Everything but that part. Because this part of the x-axis is where it drops below. So let's see, where does it start? It always starts at negative infinity, and then it goes to where? Negative 2. So negative infinity, and infinities always have parentheses, to negative 2. And since it's greater than or equal to, that means to use the bracket around the negative 2. And where else is it above the x-axis? So again, not there, but starting here. So what is this number? We found that it is 1, 2, 3, 4, 5. So from 5 to infinity. And again, it's a bracket around the 5 to infinity. Number 4, same thing. I've got x squared is greater than 64. So again, I need to set it equal to 0 first. So subtract the 64 to put it over here. So now I have x squared minus 64 is greater than 0. So here's what I'm going to put in my y equals x squared minus 64. Where is the graph of x squared minus 64 greater than 0? In other words, above the x-axis. So go to your y equals and clear it. So I have x squared minus 64, and then graph it. Okay, so again, where is it crossing? Let's see. This one's at negative 8, and that one's at positive 8. And if you're not sure where it's crossing, remember, this is a quad. If I wanted to find the zeros or the solutions, and once again, I can't stress this enough, the solutions or the zeros are where it crosses the x-axis. Well, to find the solutions of this or the x-intercepts, can't I just go to my quad, since it's x squared, plug it in, so a would be 1, b would be 0 since there is no x, and c is negative 64. That gives you your two solutions. That tells you that this does cross at negative 8 and positive 8. That's what the quad told you since that was squared. So let's see, where is it, since it's greater than, where is it above the x-axis? So once again, from negative infinity to here. So negative infinity to negative 8. And that negative 8 this time has a parenthesis around it since it doesn't have the equal to bar. What made the last problem have brackets around the numbers instead of parentheses was that it had this equal to bar right there. That's what tells you to use brackets around the numbers instead of parentheses. Since this one doesn't have one, that's why you use parentheses. So again, negative infinity to negative 8, that took into account this part that was above the x-axis. Then it drops below for a long time, and then it gets here, crosses through the x-axis again, and goes above it, which was at positive 8. So also in union with 8 to infinity. All right, number 5, 16 minus x squared is less than or equal to 0. So again, I can type that in, 16 minus x squared, and graph it. And what does this want to know? Where is this graph, which is this parabola, this U shape? 16 minus x squared looks like this. It wants to know, where is it less than or equal to 0? Again, if the x-axis is 0, here's your 0, where is this graph below it? Here and here. Those two spots. So where are they crossing? We need to know where it crosses. So it crosses at negative 4 and positive 4. So I need to say from negative infinity to negative 4 is below 0. Again, infinities always have parentheses. And then when you're deciding whether your number should have parenthesis or bracket, You look and see if it has the equal to bar. Since this one does, this one has a bracket. In union with, again, where does it go below the x-axis since we're talking about less than or equal to 0? So again, goes above it here, and it starts coming back down. There's where it touches the x-axis at 4, and then goes below it. So from 4 to infinity. All right, number 6. Now, this one will be a good idea to know where your zeros are, because look when you graph it. You have 20x minus 100 minus x squared. So when I graph this, now it's hard for me to tell just by that picture where it crosses or touches the x-axis. To get a better idea, you can do zoom. Now scroll down to 0. This zoom fit zeroes in on what the calculator thinks is the important part of this graph, and that is true. It wants to know where it touches the x-axis. Well, it's still kind of hard to tell. It's going up, it's touching the x-axis, and then it's coming back down. But let's see where it does this. Okay, if I'm not sure, remember, if I go to my program quad, that's going to tell me where it touches the x-axis. Now, be careful here. If you're going to program quad, what is A? Well, A is the number in front of x squared, which in this case, it's this number right here. So it would be -1. B is the number in front of x. It doesn't matter what order the numbers are in. B is always the number in front of the x, which in this case is 20. C is the constant, which in this case is -100. Now, look at where it says the solutions are. They're both 10, which means when I go, so that means it touches or crosses the x-axis at only one spot, just at 10. So let's go back to that graph. So even though I don't see it, when I plugged that in, it told me the answer was it's going to touch the x-axis at 10. So let's see. It wants to know where is it below the x-axis. Well, the only point on this where it's not below the x-axis is at 10. That's where it's touching the x-axis or on the x-axis, which means it's below the x-axis everywhere except 10. Which means from -infinity to 10 and 10 to infinity. The only place it's not below the x-axis is at 10, and that's because it touches the x-axis at 10. All right, last one. Number 7, x squared plus 18 is less than 5x. So again, before I plug this in, I need to put the 5x over here. So x squared plus 18 is less than 5x. So if I subtract the 5x from both sides, and I like to put this x in between these two terms, right? Because that just makes the terms be in order. So I'll have x squared minus 5x from just sliding that in there, and then plus 18 is less than 0. So let's see what this looks like. X squared minus 5x plus 18 and graph it. Oh, okay, so we're still in this funny look at, so if you have done that zoom fit for your last graph, to get it back to just the standard, what we like to see where the x-axis goes from -10 to +10, and the y-axis also goes from -10 to +10. Go back to your zoom button. And then to get it to the standard, which is what we like to start off at, it's this number 6. So go down to 6. See how that made your x and y-axis be like we like to see them. Okay? Now, Let's look. Let's do zoom 0. Look where that is. Look where that x squared minus 5x plus 18 is. It wants to know where it is below the x-axis. Well, look what it does. It looks like it comes here and it touches the x-axis and then it goes back up. It doesn't ever go below the x-axis, okay? And since it never goes below the x-axis, that solution set is called the null set. It doesn't ever go below 0. So if you're looking for this symbol, it's down at the bottom in My Labs in your toolbox, down where you have the exponent button and the fraction button. There'll be a button on this problem that has the answer that looks like that for the null set. And that's because it never goes below 0.